All right, so 13.3, we're going to talk about geometric sequences. So a geometric sequence is when you multiply to get from one number to the next in the sequence. So we talked about arithmetic, which was 13.2, where we add to get from one number to the next. Here, we're multiplying. So we just have two different formulas for when we multiply. We've got our general formula, so our rule, which would be this. It's already labeled for us. So a sub 1 is our first term. R is our common ratio. That's what we're multiplying to get from one to the next. We can do that by taking the third term and dividing it by the second term. You could also do the second term and divide it by the first, as long as you take one of the terms and divide it by the one immediately in front of it. So you could do like the fifth term and divide it by the fourth to find what your common ratio is. So it's just what you're multiplying to get from one number to the next. It is always multiplying. And then n is our number of terms. So in example 1, it says if a is equal to 3 and r is equal to 2, then we have the geometric sequence, write the rule. So a is just talking about our first term, a sub 1. R is our common ratio. So here our sequence would be 3. If we multiply to 2, what would our next number in the sequence be? Multiplied by 2. What would the next number be? 6, and the next one, 12. And then we keep multiplying by 2. The next one would be 24. So you just keep multiplying. This would be an example of a geometric sequence. We just have to write the rule here. So our rule, our formula, is a sub n is equal to a sub 1 times r to the power of n minus 1. So a sub n is equal to, our first term it gave us was 3, times r it gave us, which was 2, to the power of n minus 1. So this would be our rule. For the rule, you just keep n as n. You don't plug in anything into your n. It's just your general formula. The next part of this question says find a sub 17. So we're going to plug 17 into n. So a sub 17 is equal to 3 times 2 to the power of 17 minus 1. So we have 3 times 2 to the power of 16. We're going to put this in our calculator. You can do it by hand if you want to multiply 2 times 2 times 2 times 2 16 times, but we're just going to put it in the calculator. So 2 to the power of 16 would be 65,536, and then we're just going to multiply that times 3. So we get 196,608. All right, we're doing the same thing for the next one. It gives us the sequence. We have to write the rule and find the 24th term. So for our rule, we have a sub n is equal to a sub 1 times r to the power of n minus 1. So what's our first term? 2. Good job, guys. So a sub n is equal to 2 times r is our common ratio. What are we multiplying to get from one number to the next? -5. Perfect. If you don't see that right away, you could always do your second term divided by the first. So to find r, you can do -10 divided by 2. That would give us -5. So our common ratio is -5 to the power of n minus 1. So this would be our rule. Now, if your ratio has a negative number or negative attached to the number, make sure you put it in parentheses, especially when you put it in the calculator, because it will give you a different answer if you don't put parentheses. Next, we want to find our 24th term, so we're going to plug in 24 into our calculator. So a sub 24, or 24 into our rule. A sub 24 is equal to 2 times -5 to the power of 24 minus 1. So our 24th term is 2 times -5 to the power of 23. So I'm going to put -5 in parentheses If you put it in your calculator, don't forget to put it in parentheses. So parentheses -5 to the power of 23. And then when you multiply it by 2, it's a really big number, so the calculator, bless you, doesn't put it all in. It gives you the scientific notation of it, but it would be -2.384, and then it says times 10 to the power of 16. So this would be our answer for the second part of the question. All right, example 1C. So we're doing the same thing. We want to write the rule and find the 9th term of the sequence. So our general formula is a sub n is equal to a sub 1 times r to the power of n minus 1. What's our first term here? 1. So a sub n is equal to 1 times, what's our common ratio? What are we multiplying to get from one number to the next? 1/3. If you don't see it right away, do the second term divided by the first. So 1/3 divided by 1 would just be 1/3. So we're multiplying by 1/3 and then to the power of n minus 1. So this would be our rule. You don't really need the 1 there. It's the same thing as saying 1/3 to the power of n minus 1. Because when you multiply it by 1, it's the same. So either one of these would be fine. If you try putting it with the 1 times the 1/3 to the power of n minus 1 on WebAssign, it might tell you it's wrong just because it doesn't want the 1 there. So you could try both ways. Now we want to find the 9th term. So we're going to plug in 9 into n. So we have a sub 9 is equal to 1/3 to the power of 9 minus 1. So a sub 9 is equal to 1/3 to the power of 8. Now it says no decimals, so you can't just throw this in the calculator because your calculator will give you decimal. So we just have to do it in parts. 1/3 to the power of 8, we could do 1 to the power of 8 on top and 3 to the power of 8 on the bottom. What's 1 to the power of 8? 1. Awesome. 1 to the power of 8 is 1. And then on the bottom, we can do 3 to the power of 8 in our calculator, which would be 6,561. So our answer is 1/6,561. All right, last one we're going to do today. Here we're finding the common ratio, the first term, the nth term, and the 8th term of the geometric sequence. So let's start with our common ratio. What are we multiplying to get from one number to the next here? Remember, if you don't see it, you can always divide the second by the first term. So 15 divided by 5 would be 3. So we're multiplying by 3. So our common ratio is 3. Our first term is what? 5. Now to find the nth term, that's our rule. So a sub n is equal to, I'll write our formula here. A sub n is equal to a sub 1 times r to the power of n minus 1. So a sub n is equal to our first term, which is 5, times r, which is 3, to the power of n minus 1. So this would be our rule. Now for your rule, you just leave it like this. A lot of people want to multiply the 5 and the 3 together, and they'll say 15 to the power of n minus 1. You can't do that because of your order of operations. You have to do the exponent before you multiply. So just leave it like this. So this is our nth term. Last part of the question says find the 8th term. So we're going to plug in 8 into n. So we have 5 times 3 to the power of 8 minus 1. So 5 times 3 to the power of 7. We have to do 3 to the power of 7 first in our calculator. So 2,187 times 5 would be 10,935. So this would be our 8th term.